Hello everyone, thank you for joining this webinar. My name is Anastasia and I work as a CG specialist here at Chaos Group. In this session, I will share with you the essential steps and best practices for creating a Vray for Sketchup project from scratch. In this webinar, I will go over the process of creating a daytime architectural visualization, and I'll cover everything from setting up the frame, adjusting the light, creating and modifying materials. I'll show you how to add atmospheric effects and change the settings for final rendering. I'll demonstrate how you can use the frame buffer to make color corrections quickly, as well as how to load them in Photoshop and use them in a more controlled post-production. Before I start, I want to say a few words about the project itself. The model was kindly provided by Radek Poplavsky from Vray, and the building was designed for a person who wanted to move out from a crowded city and live in nature. It's intended to be situated in a landscape reserve, which affected the design of the building. The house is placed in a forest glade, it has big window openings to the view, and a central inner atrium. Private and living areas have southwest orientation and are open to the surroundings, while the entrance and garage area are more secluded because of their orientation to the road. Corten steel was chosen for the facade. It has a characteristic weathered look and rusty orange coloring. Here you see visualizations created by Vray, and winter setting was chosen for the renders, where the contrast between the snow and the material make the building stand out. For this webinar, we went for a summertime, and before starting the project, it's helpful to decide or even do a quick sketch of the frame and determine which parts of the building to include, where you want to position trees and plants and other entourage, as well as decide on the color palette. If you set these details at the beginning, you can use it as a reference when creating the visualization and save a lot of time. Now I'll go ahead and switch to Sketchup to start working with the scene. As you can see, I have my building and it's placed on a simple surface. The asset editor is one of the main tools where you will find everything you need to work on your project. I'm starting with the default Vray settings and will render using the CPU. I'll enable the interactive rendering mode, which will allow me to see right away any change that I make to the scene. I can start it directly from the asset editor with this button over here, or find the same button at the toolbar above. Right at the beginning, it's important to position the camera. I will use as a guidance my concept sketch that I showed you. And to save some time, I have already tested different camera positions and saved the one that I like. Then I'm going to adjust the frame. In Render Output, I will enable Save Frame, which will add a black overlay to my scene. This will show me what my camera sees. We have a few different presets for the aspect ratio. You can quickly switch between them and find the one that is most suitable for your project. I'm going to use a custom one and set the aspect ratio to 2:1. And I'm going to increase the width and the height a little bit. While the project is in progress, I keep it at lower values and increase the resolution for the final rendering. The aspect ratio will remain the same. Sometimes, depending on the project, you might need to adjust the camera exposure value to make the image brighter or darker. But the default value works for me, and I'll probably adjust it once I set everything else in the scene. The great thing about Vray physical camera is that it works the same as a real-life camera. Same exposure values used by photographers can be applied here as well. If you want, you can use photographic exposure values for various lighting conditions. Now that the frame is set, I'm going to adjust the lighting in my scene. That can be easily done by working with the SketchUp's shadow panel. They are connected, so by changing the date and time, you can control the Vray sun position. I switched between different light setups and found the result I like the most with these values. An early morning in July. Of course, you can adjust it at any time. I can leave it like this, but if you want to have even more control over the Vray sun and sky, you can go to the Lights tab in the Asset Editor and expand the settings for the sunlight. Changing the intensity multiplier will affect the brightness of the sun and can be used to adjust the default brightness. Value of 1 is correct from a physical point of view, but if you want to adjust it for artistic purposes, don't be afraid to experiment. I'll change it back to 1, which can be done from the settings or directly in Lights tab. Next we have Size Multiplier, which affects the visible size of the sun. This includes the appearance of the sun disk as seen by the camera and reflections, as well as the blurriness of the sun shadows. Higher values will create softer shadows, and I'll use a value of 3 as I think it is enough. If you want to change the appearance of the sky, you can try different sky models. They specify the procedural model that will be used to generate the Vray sky texture. By default, it's set to Hosek et al., which is the newest of them, and I'm going to leave it as it is. The turbidity parameter determines the amount of dust in the air and affects the color of the sun and sky. Smaller values produce a clear blue sun and sky, while larger values make them more orange. Next we have ozone, which affects the color of the light. Values closer to 0 make the sunlight yellow, and values closer to 1 make it blue. Depending on your project, you can experiment with these values or, like me in this case, leave it by default. Changing the ground albedo color will affect the gray color you see at the horizon. For a sunset, for example, you can set it to orange. I'll set mine to a darker blue color. Changing the blend angle will affect the blending between the horizon line and the sky. Larger values will produce a softer horizon line. With the horizon offset, you can manually lower the horizon line if, for example, your building is in the mountains. I'll leave everything by default except for the size multiplier and albedo color. Everything looks fine, so I'll move on to adding materials. If I go to the Materials tab in the Asset Editor and expand the menu to the left, you will find the material library that comes with Vray for Sketchup. Currently, we have over 500 ready-to-use materials that are separated in different folders. We have bricks, concrete, glass, fabrics, metals, and many more. I'll start with the metals and will search for an iron material using the search bar. I want to apply it to the chimney, the beams in front of the facade, and the joinery of the windows. And I will start render in viewport to make it easier to select and see the result. If you right-click over material you want, you can choose Apply to Selection, which will assign the material, but also it's going to automatically add it to the material list of your project. I'll enable the viewport render region to avoid rendering the whole viewport and instead focus only on part of it. If you want to be able to see the actual model, you can lower the overlay opacity using the Ctrl and plus sign or Ctrl minus. Now I'll select the glass and in the same manner will apply the simple glass material from the library. Okay, next I have the base of the building and I'll show you how to apply material to a whole layer. I'll go with Concrete Simple D material, just drag and drop it to the material list, then right-click on it and choose Apply to Layer and select the corresponding layer that you want. This is useful when, for example, you have many different objects in one layer and you want to assign the same material to all of them. I'll add another region to work with the ground. You can do that by holding Shift while drawing a region. In the library ground folder, I'll select Grass A material. You can see that the pattern is very small right now and it needs to be adjusted. Actually, I want to note here why I used a manually drawn ground plane instead of an infinite plane. When it comes to mapping of textures like the grass here, infinite plane is best used with simple colors applied to it. Modifying the scale of the current material is very easy. Simply go to the Sketchup's material panel and increase the size. You will notice that some materials from the library have a number in the name. Only materials with bitmaps have them. This is an optimal size for the sample, but you can adjust it to your liking. Also, keep in mind the units of your project. Mine are set to centimeters, but if you are working, for example, in inches, just type 200 centimeters at the end and it's going to adjust accordingly. Next, I want to create a curtain material for the panels of the building. I'll stop the viewport rendering and I'm going to focus on these panels and begin with creating a new material from the button in the left bottom corner. I'll use a standard generic material. Then I'm going to assign it to the group of panels and rename it to curtain so it's easier to find. Let's start with the diffuse of the material. I have only one texture for it, but if I use it the way it is, it's going to look the same on all panels. To create variation, I'll choose a multi-sub texture. The Vray multi-sub texture distributes multiple textures to many objects via one single material based on specified IDs or a random distribution. 4 textures should be enough in my case. Currently it's black since this is the default color, but I can change it to different colors or use a bitmap instead. Here I'm going to load the bitmap I have prepared for the diffuse. And I'll copy it in the other textures and then switch the get ID from the current object ID to random by render ID. The pattern on the panels seemed too small, so to fix the scale of the texture, just like I did with the grass, I'll adjust the size from the Sketchup's material panel. I'll try 300, which I think should be enough. Okay, that looks much better now, but it looks all very uniform. I'll fix that by adjusting each of the bitmaps. Simply change the color space of the image from screen space as RGB to a custom one and slightly adjust the value to something like 0.6 for example. I'll do the same for the others as well. I'm using different values, but keep in mind that bigger difference in them will create a very noticeable effect. Let's see how it all looks together with the rest of the building. I think that the last bitmap is a bit too dark right now, so I'm going to change the value to something closer to the rest of the panels. Okay, I think it's better now, but although there is a difference in color, the pattern remains the same and it's very noticeable. I'll change that by expanding the texture placement rollout and adjust the horizontal and vertical offset of the bitmap. I'll use smaller values and will do the same for the other bitmaps as well. There are no specific numbers, just try different ones until you like the result. You can always come back and change them later. Okay, we are almost done. In the first slot, you can notice that I didn't change the color space. The bitmap has its original color and the rest are simply variations of it. Next, I'm going to work with the reflections of this material. Again, I have only one map for the reflections, but if I use it as it is, all panels are going to have the same reflection pattern. Just like with the diffuse, I'll use multi-sub texture, and actually I'm going to copy the whole set. I'll replace each bitmap with another image just for the reflections. And since I want to create variation only in its position, I'll switch back the gamma to screen space as RGB. To adjust the sharpness of reflections, I'll again copy all of this to the checker box next to reflection glossiness. Then I'll change the bitmap to another one prepared just for the glossiness. And I'm going to load it in the all four variations. To make this process even faster, I'm just copying and placing the path to the image. Okay, I think I'm ready with reflections. I'll show you how they look isolated in the reflections render element. Before I move on, I'll do the same for the bump slot of the material. Just paste the multi-sub texture and replace the bitmap with the one for the bump. This will add even more detail to the overall look of the curtain material. Of course, these are not necessary steps, but they will help you avoid a uniform or repetitive look. And if you actually want to have visible tiling, you can skip these steps altogether. I'll decrease the amount to make the bump less strong. I noticed that I haven't applied this curtain material to the wall behind the beams. I'll engage the lock camera orientation. This will allow me to move the camera in the SketchUp scene while keeping the same framing for the rendering. I'll apply curtain to the wall behind the beams and concrete to the element below the roof. Let me just find it in the material list. And actually, I see some pattern repetition, so I think I should adjust the size as well. I'll use 200 centimeters. I'll disable the render region and let's see how the whole scene looks at this stage. Let's move on to the ground in front of the building. It looks flat, and to add more realism, it's a good idea to create some detail. You can use SketchUp sandbox tools to model portion of the terrain or model it in another software and import in your project. This was the approach for this scene. I'll enable a layer with the ground segment. It was modeled in ZBrush and imported in SketchUp. But as I said, you can take advantage of the sandbox tools and model the ground directly in SketchUp. For this, I want to create a material that combines grass and soil for the tracks. I'll start with the generic material and rename it to ground. Then I'll apply it to the object. For the diffuse, I'll use a mix map which allows for two textures or colors to be blended together. Currently, it renders black because that's the only color that I have. Instead, I will use a bitmap of the grass that I already have in my scene. So let me find it, copy the diffuse, and paste it in texture B of the ground material. I can't see the pattern of the grass because my object doesn't have proper UVs. In situations like this, you can use the Vray UV tools. Simply right-click on the object and select the projection type. In my case, Tree-Planar Projection World will work. When used, the texture materials get projected to each geometry face, not the object itself. Now, the pattern is visible, but it's too small, so I'll just increase its size to 200. Looking much better. For the other texture, I'm going to use a bitmap from another material in the library. I already added it to my list and it's called Soil C01. Again, copy the bitmap and place it in the slot of texture A in the ground material. The result I get is a bit washed out because currently I have equal mix between the two textures. Instead, I will use a black and white mask quickly prepared for the ground. If you are using Sandbox, for example, or you want to create a precise mask, you can set your camera to the top view, switch to parallel projection, and now you can either do a quick render or export it as a 2D graphic and use the image as an overlay in Photoshop to create a mask. I'll get back to my shader. To control the mask's scale and position separately from my current material, I'll use a tree planar map and load the mask. The tree planar texture works by projecting one or more textures along the object's space axis depending on the surface normal of the shaded object. I'll use only one image for all axes and start with adjusting the scale. I will probably need a higher value, but it depends on the size of the mask you have prepared. You can already see how it works. Now I need to rotate the bitmap and position it. It can be done by rotating it from the texture placement rollout. To adjust the placement of the texture on the ground surface, I'll use the texture transform of the tree planar map. After some tests, I found that the values that work best for this mask. In my case, the positioning of the map itself doesn't have to be perfect, but again, this depends on the mask you are using and the precision you want to achieve. I'll switch back to my view and remove the render region, and let's see how it all looks together. It's okay for this stage, but you can have realistic looking grass using 2D texture. So to improve the look, I'll use Vray Fur. It is generated only during render time and is not actually present in the scene. You can use Vray Fur not only for grass, but any other fuzzy objects like carpets or blankets. To create the Vray Fur object, I'll select the mesh from the scene, then click on the Fur button. Keep in mind that to create it, you need a group or component object. This is how the result looks with the default values. I'll use a render region to render faster, and I'll start by adjusting the length of the blades. I'll try with 10, but that might be too much. Keep in mind that the length parameter is always measured in inches, even if the units of your projects are set to something else. I think they're a bit too long for my scene, so I'll decrease the length just a little. 8 should be enough. Now let's focus on a smaller segment and adjust another parameter. You can work with the thickness of the blades or change the bend and many more to achieve different looks. I leave mine at default and will add more variety to the grass because right now it all looks too uniform. In Variance Rollout, you can increase the randomization of parameters like direction, length, thickness, and more, but I'll adjust only the first two to create a slightly messy look. When created, Vray fur will use material that is assigned to the object it is applied to, but you can change it to something else. Just enable the material rollout and you can choose any material from your material list. Actually, first I'll add another grass material from the library called Grass B and will assign it to the Vray fur. Now I need to remove the grass in the tracks, and for that I will copy the mask I used to mix the two textures in the ground material. Since it's already positioned, I won't have to do additional adjustments. I'll place it in the density map checker box. Black areas of the mask mean no fur is generated in these areas, and white color means the opposite. There will be 100% fur generated. Alright, we can see the tracks now, and usually in situations when I have a bigger segment with grass, I will enable the level of detail rollout, meaning that Vray will generate less fur geometry for parts of the scene that are far away from the camera. This is done by decreasing the density of the first strands and increasing their thickness. I'll just specify the distance from the camera at which Vray will start implementing the level of detail adjustment. Try to optimize your scene by separating the ground in segments and applying fur to those areas that the camera actually sees. Okay, I am done with the grass in this project. Sometimes, after you are done working with materials, you will end up with a scene that looks like this, showing the Vray texture helper. This is not going to work if, for example, you want to take screenshots of the project and use them in a presentation. I'll show you how to adjust it and enable the textures to be shown in the Sketchup's viewport. I'll start with the ground material. Right at the bottom, you will find Binding Rollout. It enables connection or binding between Vray and the corresponding representation of material in the viewport. When the material has a texture, you can enable to see in the viewport either a texture helper or set it to auto and choose the texture you want to display. Texture helper will appear in the Sketchup's viewport for all complex Vray materials like blend, multi-material, toon, and so on. Also, it's going to appear with materials with textures other than bitmaps in their diffuse slot. In this scene, this is the case with the ground shader, for example, which has two bitmaps mixed together. In case I want to see in the viewport the grass texture from this material, I need to switch the binding to auto, find the bitmap I want to see in the viewport, and click on the eye icon. I'll do the same for the curtain material. Simply choose one of the used bitmaps and once again click on the eye icon. If you want to use a different image for the viewport without affecting the Vray material, simply disable the texture binding and in Sketchup's material panel, select an image that you want to use. Just as an example, I will use one of the maps for the curtain. You will see it in the viewport, but if rendered, the curtain material is going to look the same as before. I'll turn on back the binding, and I think I'll leave it as a bitmap instead of the texture helper. I'll show you how to work with heavy geometry in your scene. For example, trees, plants, and furniture can have hundreds of thousands of polygons, and they can significantly slow down your viewport. When it comes to heavy models, Vray proxies are a great way to optimize your scene because it allows geometry to be imported from an external mesh at render time only. The geometry is not present in the Sketchup scene and does not take any resources. I opened a different file with a plant. If you're using models downloaded from the warehouse, test them out in a separate project before importing them into your model. This is how it looks like when rendered, and it currently has two materials applied to it. It's important to assign materials before exporting the geometry as a proxy, because this will automatically create the corresponding face IDs. They are needed to later tell Vray to which faces of the model to assign each material. You can now export this model as a proxy, but let's say I already have copies of it placed in the scene. To avoid manually replacing each one of them with a proxy, I can instead do the following. First, open the component. Usually, it's going to have groups or components inside of it, and it's recommended to clean all internal structures prior to exporting it. Here I have one group for the leaves and one for the stem. I'll explode each one of them. Then select all and make a new group. While still in the component, I'll export it as a Vray proxy using the Export as VR Mesh button. A window will show asking me to specify the path for exporting the proxy, as well as options to control the viewport representation of the proxy. It is a good idea to name your component prior to converting to VR Mesh. This way, the resulting proxy file and its multi-material will all be named accordingly. I'll decrease the faces in preview, which specifies how many faces are going to be used to show a preview of the proxy in the viewport. Then click Export. As you can see, all plants in my scene are replaced with the proxy. In the asset editor, there will be a material created for the plant, and it has two submaterials created as placeholders. And if we render it, it will look absolutely the same. Even if you copy the proxy around, it will remain as one object in the asset editor. You can now add this proxy together with its two materials to your scene by saving it as an SKP file. I'll open a new file and import the SKP that I just saved. It will import with the materials and the proxy, but keep in mind that if you want to give this file to someone, you need to provide all assets that were used for it. Now, back in the previous file, I'll show you how to scatter the proxy over a surface and add randomization. I'll leave only one plant and delete everything else, and also enable a ground layer that I have here. I will use two extensions from the Sketchup extension warehouse. First one is called Ray Tracer by TomTom. Using the spray can, I'll adjust its radius and just click a few times on the surface. Alright, I have many copies of the plant, but they all look the same size and orientation. I'll select them from the asset editor. Actually, let me change the preview type to a bounding box so it's easier to see. You can change the preview type of the proxy depending on what you find more convenient. And once they are all selected, I'll use the Chris Fulmer tools, Scale and Rotate Multiple. Here I'll decrease a little the maximum scale to something like 1.3 and change the maximum rotation to 360. Now the boxes are randomly rotated and resized, and if we render, this is how they will look. The trees for my scene were created using this approach. To speed up the rendering, I'll disable the grass for now. This time, I'll load a pine tree using Import as Proxy or VRC button. Then I'll place a few copies in my scene and render. I'll show you how to load materials for the pine trees. As I mentioned, the initial proxy submaterials are created only as placeholders to illustrate where each one is applied and ease the process of reapplying the actual ones. You'll see that at first they render in different colors because proxy files don't hold the actual materials. I'll replace the first one with a brown material for the stem of the pine. In the second rollout, I'll choose a material I have for the needles, and in the last one for the pine cones. To save some time, I already have all trees placed in my scene, so I'll delete this and unhide the layer called Forest. These are all proxies with the same materials that I just used. Notice how I have some trees behind the camera. Although I cannot see them, they throw shadows that are visible in the frame and create more interesting look. In the same way, some pine cones and dandelions were imported in the scene as proxy, scattered and randomized using the two extensions. And I know that I should have one plant right here that is currently missing. You can see that here I have an exclamation mark that the proxy could not be found, but in case of a bigger scene with a lot of assets, it might be difficult to track what is missing. So an easier way to manage the assets in your scene is by going to Extensions, Vray, File Path Editor. You will find all proxies, VR scenes, bitmaps, IES file currently used in your project. And if something is missing, you will see a red square. From here, I can quickly repath the asset. This can help you a lot if, for example, some assets were moved to a different location. Okay, I'll switch back on the grass to see how the image looks. I think now it's a bit too dark, so I'll adjust the camera's exposure value to 13. And instead of the clear sky, I want to have clouds, so I'll replace the sky with an HDRI. I'll open the Environment drop-down menu, and in the checker box I have the sky loaded. I want to keep the current light from the sky and use an HDRI only as a background. I'll use Environment Override for that. With a right-click, copy the sky, enable the GI skylight, and paste the sky in the corresponding checker box. So now, if I disable the sky from the background, Vray will use the dark color selected, but the light in my scene will remain the same. I can change the color to something else or enable back the use of a texture and choose bitmap to load the HDRI I have selected. Currently, I don't have the clouds, which means that I need to fix the texture placement. The HDRI I'm using is a 360 image. That's why in texture placement, select type, I should choose environment spherical mapping. Now I'll just rotate it horizontally until I like the result. I like the placement, but the clouds seem too dark, so I need to increase the multiplier. And let's see the overall result. I'll slightly adjust the exposure value one more time to make it a bit brighter, and I'm going to set it to 12. Okay, almost done. There are a few things that I want to adjust before setting for final rendering. I would like to add some depth to the scene. In volumetric environment, I'm going to use aerial perspective, which simulates the aerial perspective atmospheric effect, or the result of viewing objects from a distance through the Earth's atmosphere. The effect is similar to fog or haze. It simulates light scattering from the sun and sky, which makes it a fast effect to calculate. The default settings are too strong for my scene. I'll start with adjusting the visibility range, which controls how far away from the camera the aerial perspective appears. I'll try with 12,000. Lower values will bring it closer, and larger will reduce the effect. The height controls how far from the ground this effect will be visible. I'll try 30 and see how it looks. I think visibility range could be a smaller value. Okay, to create different looks and atmosphere, you can also change its color. I'll add a blue tint. To see the effect isolated, I'll show you the atmosphere render element. Before we move on to the settings for final rendering, there is one small detail that I want to adjust. It might not be very noticeable in my project at first, but it can be used in some situations where you have a higher building and it's adjusting the vertical lines during render time. If you go to Camera, Effects, Effects Rollout, vertical tilt can be used to achieve a 2-point perspective effect or adjusting the vertical lines. I think for my project, a smaller value will work better. Alright, now that everything is set, I'll show you how to adjust the settings for final rendering. First, I'll increase the resolution to 2000. Then I'll disable the interactive rendering and adjust the quality slider to high or very high. In case you want to do compositing after the image is rendered, you can add render elements and you're ready to render. And for an even faster results, you can test out the Vray Cloud service, which is currently in free beta for a limited time. It's a great solution for those who have a lot of projects at the same time or very tight deadlines. You can get your render in a very short time while keep working on something else. And the best part is, it doesn't require any technical knowledge. Just like you would set the scene for production rendering, simply choose the Cloud button and Vray will take care of the rest. It's going to analyze and upload your scene with all the assets. From this page, you can create different folders for each project. If you want, you can change the name of the job or adjust the resolution and submit it for rendering on the cloud. In your browser, you can track the progress of the render, pause it, cancel it, or see a preview directly in the browser. You can render at the same time up to 50 jobs and track them in the queue menu. There are how-to and frequently asked pages providing additional information. We can follow the progress of the jobs on any device, laptop, phone, or a tablet. When a rendering job is completed, you will receive a notification. I already rendered this image, and I'm going to show you how you can do color corrections directly in the frame buffer, save them for later use, and import them in Photoshop. I'll start by enabling the history in the frame buffer, which can store a list of recently rendered images and switch between them or compare them. To do that, you need to specify the path to a folder where the history will be stored. Currently in my history folder, I have the rendered on the cloud image. Keep in mind that it can load and store only files as VR image format, which is the native Vray format. It can be opened with the frame buffer, it stores render elements, and you can apply color corrections to the render. Of course, you can save your image directly from the frame buffer and choose one of the many formats available. In case you want to save not only the image but also the render elements in separate files, just hold on the icon and choose Save All Image Channels. Again, choose the format you want and you will have all the files. There is also another way to save your renders. In Settings, Render Output, you can enable the Save Image Rollout, and once you specify a path where you want your files to be saved after the rendering is finished, you can choose between the formats. This gives you more control over each type in terms of compression and bits per channel. A higher bit depth means that you have more room to push and pull colors and tones before you start seeing artifacts in your image. This means that in compositing, you have much more flexibility using a format that supports it. Which format you should use is a personal preference. One of the most popular formats is the JPEG file format. Unfortunately, every time a JPEG image is saved, it loses some quality. If you are using JPEG, you're limiting your bit depth to 8-bit. PNG is another popular format. It is not an HDR, but it can support up to 16-bit images. There are also TIFF files and EXRs. Both are HDR and can support up to 32 bits per channel. Another great feature of the EXR format is that you can embed multiple render passes into a single image sequence. In my project, I saved everything as a separate EXR files because Photoshop won't read single multi-channel EXRs. And before I move to Photoshop, I'll make some color corrections to the render directly in the frame buffer. To enable the type of color correction, just click on the checkbox next to the name. If you want, you can adjust the exposure, highlight burn in case you have overexposed areas in your image, as well as increase the contrast. Next, you have color balance, where higher values will make the image warmer and lower values colder. I'll leave mine at 7600. I'll slightly adjust the hue and saturation. In case you don't like the result, you can simply reset all the values for the category. Color balance allows you to adjust separately the shadows, midtones, and highlights, or all of them together. I'll add a bit of warmth to the shadows and midtones, and make the highlights slightly colder. Next, I'll increase the contrast using the curve. And once I'm done, I can save the color corrections from the Globals menu. Keep in mind that if you want to use this color correction in the frame buffer, you need to save it as an VCC-GLB file. But if you want to use it in Photoshop, you should switch the type to LUT file or cube format, which is what I'm going to do here. Let's see how to load this cube file in Photoshop. This is how the raw render looks right now. You can use it as it is, but if you want to have more control in compositing, you can load the render elements needed to create the Beauty RGB pass. In my case, I have reflections, lighting, background, atmosphere, specular, refractions, and GI. Select all of them and switch the blend mode from normal to linear dodge add. As you can see, it looks like the RGB. Next, I'm going to create a color lookup new adjustments layer. Click on Load 3D LUT and select the LUT file I just saved. With this as a starting point, I then added other adjustments layer for some of the render elements. I added exposure adjustment layer to enhance the overall reflectivity as well as just for the curtain material. In the same manner, I adjusted the background. I increased the strength of the atmosphere and added photo filter to match it better with the sky. exposure adjustment layer for the refractions, and that was it. That's how I got the final image. As you saw, compositing using render elements give you a lot of flexibility and control over your image. Alright, this is it for this webinar. Thank you very much for attending. I hope you found it useful. You can download a 30-day free trial to try Vray's newest features and see how they fit in your workflow. If you want to learn more about our latest updates and releases, visit our webpage chaosgroup.com. You can find more detailed information of the different features and how they work on our official documentation site, docs.chaosgroup.com. And don't forget to check our YouTube channel, Chaos Group TV, where you can find a lot of tutorials for Vray, for Sketchup, and many more. Thank you for being part of this Vray experience. See you next time!